Greetings everyone! Today we're going to explore solving systems of equations, specifically using elimination. We do have our notes book for this, so make sure you have access to this. If you don't, this is easy to jot down in your notebook. Alrighty, for this lesson we're going to jump straight into the examples. We're going to summarize the steps later. But the general idea for elimination is making sure that like things are lined up. The x's are lined up, the y's, the equals, and the constants. The next sort of general concept is old school addition, I like to call it, meaning a big bar with a plus sign. And we are going to add our like terms. -4 plus 4 is 0. My x's cancel out. Let's look at the y's. -2 plus 8y is positive 6y. The equal signs fall down. That's the same as always. -12 plus -24 is -36. Now look at this. We ended up with a single variable equation. That's much easier, right? Now instead of timesing by 6, let's divide by 6, and we have our first variable. Just like in substitution, need to see that video. If you know one number, you need to find the other number. Now, to find that other number, you actually get to plug in -6 into either equation. So let's say I pick the first one. What that means is I'm going to write the first equation. Wherever there's a y, I put a blank. And wherever there's a blank, I put the value for y. Let's calculate. -2 times -6 is positive 12. I'm going to subtract 12 to the other side. -4x equals -24. And if I divide both sides by -4, I arrive at x equals positive 6. Now I got nice clean numbers, but here's the thing. You should really plug them in to make sure, especially on an assessment. So what that means is I'm going to take each equation and I'm going to plug in the letters with numbers. So instead of x, 6, instead of y, -6. And if I just do a quick calculation, oops, and then I calculate, I should get whatever the answer is. Let me try the second equation. Watch this. 4 times 6 plus 8 times -6. That would be 24. Subtract 48. Guess what? That's -24. So I proved by plugging them into both equations that my solution is correct. Now again, I'm just going to give you the heads up on this one. We're just going to jump into straight old school addition. Everything's lined up, right? See the x's, the y's, the equals, the numbers. That has to be true. So if I combine, what's x plus -x? That's 0. Interesting. Let's go again. What's positive y plus -y? 0. Okay, let's drop down the equals. What is -2 plus 4? 2. Let's simplify that. Is 0 equal to 2? No. This is one of our favorites because they're usually faster, right? No solution, meaning there's no numbers in the world that would be true or make those systems of equations equal. All right, let's take a look at example 3, and this one is going to require us to stretch our thinking. I said there's sort of two things we need to think about. Our equations need to be lined up. And second of all, I need something to go away. I need something to eliminate. So first of all, I need to rearrange. I need things to be lined up. So I'm going to rewrite this first one as is because it's already kind of in that neat little standard form, right? But the second equation, I'm going to add 6x over. Because if I do that, now I have 6x minus 1y equals 7. All right, they're lined up. Check. Next, I need something to eliminate. Uh-oh, nothing's going to eliminate, meaning if I draw my old school addition bar, nothing's going to go away. But can I make a letter go away? Let's pick a letter to eliminate. I'm going to pick the y's because they're smaller. All right, so let's look at the y's. I need them to both have the same factor, meaning I'm going to have to multiply that second equation by 3. Okay, so if I do that, I'm going to have negative 3. Well, negative 3 and negative 3 doesn't go away, so I have to multiply it by a negative 3. Let me show you why. Okay, I'm going to carry down the first equation, right? I'm repeating that. But let's take that second equation and I'm going to multiply it by negative 3, by negative 3, by negative 3. What you do to one, you do to all. You multiply all of it by negative 3. Now if I do old school addition, cancels, 0. Cancels, 0. Equal sign, cancels, 0. Does 0 equal 0? Yes. So this is a special one, right? We've got infinite many solutions. If it's a true statement, this will always be your answer. All right, let's follow this same idea. We want to line up and we need something to eliminate. So I'm going to rearrange that first equation. How can I do that? Well, I'm going to add 2x over to the other side. So that leaves me with a 4 on the right side, a positive 2x, and a negative 1y. I'm going to rewrite that second equation below it. I just want to see them lined up. Okay, that looks better. They're lined up. Next, I need something to eliminate. Should I try to get rid of the x's or the y's? Definitely the y's, because look, they're almost the same number. Now, they are the same number, but I want them to be opposites, right? How do I get rid of a 5? I subtract 5. How do I get rid of a negative 1? I need to add 1. So here's what I'm going to do. I'm going to times the entire second or first, you get to decide, equation by negative 1. So let me rewrite this system. The first one's going to stay as is. But now the second equation is going to look like this. I'm going to multiply every piece by negative 1. See what happened? Now when I do old school addition, 2 and negative 3 is negative 1x. Negative 1y plus 1y, perfect, that's our elimination. The equals falls down. 4 plus negative 2 is 2. Let's solve. Instead of times negative 1, let's divide both sides by negative 1. I got an answer so far of negative 2. There's my x value. Now I need to find my y value. You get to pick where you plug that negative x or that x value into, the first equation or the second one. I'd go back to the beginning, the originals. It doesn't matter. I'm going to pick the second one. No particular reason. Instead of x, I put parentheses. Instead of parentheses, I plug in a negative 2. Let's start solving this equation. I'm going to add 6 over, divide by negative 1. I got a negative 8. Now, remember, don't walk away. Check your work. Negative 8 equals 4 minus 2 times negative 2. That'd be 4 plus 4. Does that equal 8? Yes, so far so good. 3 times negative 2 minus negative 8. Does that equal 2? Let's see, that'd be negative 6 plus 8 equal 2. Yes, right? Like you can use your calculator, you can do mental math, you can write it out like I did, but because I checked my work, I'm now confident that -2, -8 is my answer. All right, let's take a look at this one. First thing I notice, are they lined up? Yeah, they are. They're lined up in a different way, but that's okay. Doesn't matter as long as they're lined up. Next, I need something to eliminate. I'm going to deal with the y's, right? They just look easier. I'm going to multiply the first equation by -3. See how that's going to make stuff go away? I'm just going to move it down here. -3 times y is -3y. Negative times negative is positive. 2/3 times 3 is 2. Use your calculator if you need to. -3 times -3, positive 9. Old school addition. 3y and -3y cancels. Interesting. -2x, positive 2x cancels. Keep going. 12 plus 9, 21. Does 0 equal 21? Nope. No solution. All right, let's take a look at this last one. First of all, are they lined up? Yes, they are lined up. Everything x's, y's equals constants. Next, something needs to cancel. You pick. Do you want to deal with the y's or the x's? Well, I'm going to pick x's just because they're smaller. But we're running into an issue here. Here's a special case. If I look at the x's, one's positive, one's negative. That's good. But can a 2 become a 5 easily? Ooh, not without fractions, right? So here's our special case. If one equation can't be multiplied to get the other one easily, you are going to have to multiply both of them. I'm going to multiply the first one by 5, and I'm going to multiply the second one by 2. See how I multiply by the opposite factor? Very important. Let's take care of that. Distribute the 5 times 5 times 5 times 5. Let's look at the second equation. Times 2 times 2 times 2. Okay? If you can't multiply one equation, you need to multiply by both. How do you know which numbers? Just multiply by the opposite number. Old school addition, let's line them up. I arrive at a 0 and a 0 and a 0, which, as you expected because of the layout of our notes, is going to be infinite many solutions. All right, so in this notebook, you do have a little bit of space, probably up top, to fill in some steps. So let's summarize what we did. The first thing when solving systems by elimination, we made sure to line the equations up. I'm going to generalize them, line them up. X's, Y's equals constants. Okay, the order of those doesn't matter. What matters is they're lined up. Second, we choose a variable to eliminate. So you're going to pick the X or the Y. You're going to multiply if needed to cancel, right? So if I needed to multiply one equation or both equations, and then we took care of I'm going to call it old school addition, not mathematical at all, right? But let's call it old school addition. And then solve. And then if needed, solve for second variable. Right? So if I found an X, I need to find the Y. If I found the Y, I need to find the X. And that's if needed. Sometimes they all cancel, right? And you're done the problem. So line them up, choose a variable to eliminate, multiply that variable if needed to get something to cancel, old school elimination or old school addition to take care of that elimination, solve the equation further, and if needed, find the second variable. Alrighty, I have an extra example here because I wanted one that sort of involved all of the steps that could possibly happen. So if you get stuck on a problem, this would be the go-to example for help. First step, I need to line up my equations. I'm going to kick that 8y to the left side. So I'm going to subtract 8y to the left, and I'm going to carry down that second equation. All right, so now they're lined up. So all I did was this, right? I subtracted the 8y over. Step 2, I need to choose a variable to eliminate. Well, I'm going to deal with the x's. Now, I can't multiply them by one or the other. So I'm going to multiply the first equation by the 4 and the second equation by the 7. But you'll also notice they're both negative. I need them to be opposite signs. So I'm going to make the first one -4. All right, so let's multiply. -7 times -4. -8 times -4. 9 times -4. Let's take care of the second equation. -4 times 7. See, that looks good, right? Let's keep going. 9 times 7. 22 times 7. So you're getting some bigger numbers here. That's okay. Oops, and it should be a negative. All right, so even though they're bigger numbers, it will still work out. So next, old school addition. Step 3. We're going to draw that addition bar. 28 plus -28 cancels. Perfect. We needed something to cancel. We needed something to eliminate. We've got a 95y. -36 plus -154 is -190. Step 4, solve. So instead of times 95, let's divide by 95. Y equals -2. Step 5, if needed, find the other variable. Well, it's needed because so far I've just got a -2. Let's plug in -2 into either equation. I'm just going to choose the first one, no particular reason why. Wherever there's a y, I put parentheses. Wherever there's parentheses, I place -2. Let's calculate. -7x, that would be 9 subtract 16, that'd be a -7. Oh hey, x equals 1. Perfect. As always, check your answer if you're not sure, but I wanted to show you an example that has every possible step. As always, please make sure to check out Google Classroom to see what your task is to practice your elimination method. Let me know if you have questions. Seek out help in the Sabre Center if you need. If you would like some other instructional video supports, let me know. And until next time, have a good one.